from 1985 to 1987. Also a Technical Service Engineer at Sony Service Philippines from 1987 to 1989 and GM Philippines Incorporated from 1989 to 1995. Technical Director, Optical and Wireless Technologies and Solutions Group, EC&M Corporation to discuss about ITUT Recommendation L-400 Fiber Optic Splices. Please welcome Engineer Alfredo A. Carbonell Jr.
Good evening. Ina. So, I'll be discussing ITUT Recommendation L-400. This is the scope. Actually, this is L-400 covers a lot of standards for not only for fiber optic splices but all outside plant. And today, we will be discussing only L-400, focusing on fiber optic splicing. In this section alone, actually this is around 120 page, no? And ang kanyang font is 10. No? So, but I will try to squeeze it in hopefully 30 to 45 minutes. Okay. So this specifically discuss about methodology, guidelines, and testing. So right now, Sir Gerhard discussed about yung fiber optic, about yun ngayon yung ginagamit in connecting all the cell sites, mobile stations, and it started when internationally using for domestic backbone network. Then later on, nagkaroon tayo ng mga before kasi from central office to the house, dadaan muna yan ng copper. But now, nagkaroon ng cabinet, naglagay na rin ng fiber optic doon. And then, after that, nagkaroon na rin ngayon ng almost all of the mobile stations, or yung mga cell sites natin are connected via fiber optic. And now, meron natin tayong fiber to the home using the GPON technology. And at this discussion, we will be discussing only about single mode, more on the outside LAN. And dito, you can see the evolution of the single mode fiber optic. G651 is for multi-mode, so it is used for local area network. But again, since we will be fiber optic, one of the advantages for long distance, it is using first G652, the first single mode fiber that is used by telecoms. And then later on, they want to increase the distance. They have come up with several versions of single mode. We have the G653, G654, G655, G656. And all of these single mode are designed to make sure that we have the highest speed. Right now, like in G656, it is being used in the regional domestic fiber optic network, and it is using the DWDM running at 100 gigabits per second. So ganun kabilis siya, and multiple of that, yun ang nako-connect sa mga different parts of the country. And right now, sa mga bahay natin, we are using the G657, which is the belt sensitive fiber. And since what I'll be discussing today is, kasi sinasabi nila na fiber, it's not anymore current, like electronic current. This is using light. And na umaga, we talk about solar power, that is light. Ito light din, but this one is signals. And after ito may evolution ng fiber to the building, wherein from the central office to a certain building, it is connected to fiber optic. But unfortunately, yung fiber optic cable are only limited to 4 kilometers. Kaya for every 4 kilometers, kung mahaba yung location of building from the central office, so So magkakadkad ka ng kable. So if it's a 20 kilometer, so you need around 5 reels, 4 kilometer. So mag-splice ka ngayon dyan. And the last mile within the building are copper. But we'll be discussing more on the fiber. So right now, ito yung technology na ginagamit natin, fiber to the home, the GPON, no? Gigabit Passive Optic Network. And it is composed of the active equipment, the OLT, optical line terminal equipment, and on the client side, it is the ONU, optical node unit, no? Nagkaroon lang ng terminology difference between European and dito sa atin sa Asian, because in other countries, ONU is a unit na maraming clients. But here, we are using ONU, baligtad. Dapat ang terminology sa ibang country, ONT, Optical Node Terminal. In this technology, ginagamit natin 1490 yung downstream for data. It's around 2.5 gigabits per second. And upstream naman from ONU, up to the pabalik naman sa OLT is 1310, and the bandwidth is 1 gigabits per second. And here, ito yung pinaka-passive optic network. And ito yung ito yung pinaka-critical dyan. Because right now, the tendency of the, like for example, the telco and even cable TV are now replacing all this coaxial cable, the copper cable, with this PON. No? Pero, with that PON, no? Kasi ngayon, with that PON technology, in one fiber, no? It can now be distributed to 64 subscribers. No? And this is just a conventional. Now, using a higher power OLT, it can go up to 100, or you have to double that, 128 subscribers. No? So, yan ang natin. Yung ginagamit natin GPON technology, that was around 2004 pa, kaya lang in-implement sa atin. But now, meron nang ginagamit na XGPON, no? Meaning 10 gigabits ang downstream mo, ang upstream mo is almost the same. No? Okay. So here, sinabi natin maganda, matipid, because there is no more, at now na passive, there is no more power needed in the outside plant. No? But the problem there is these passive elements, no? Marami tayong loss. This is a splitter, and for every splitter, there is a loss of around 9.6 to 10.2 dB. No? So if you cascade that, mangyayari, at the end of, before the ONU mo, i-add mo yung dalawang loss niyan, no? So around 20 or 19 to 20. No? So yun na yung signal na makukuha makukuha ng ONU mo. That's why we have to be critical about these splices. Sa portion na to, ito yung mga nasa poste, we call the snap, no? Ginagamit natin dyan ay mechanical. So, yan kasi, this is more of, tawag natin dito sa access side na. So, we have to make sure that we will be using a cheaper method of installing it to the house. That's why mechanical splices are allowed here. But in this core, part, fusion splices should be used. Okay. And right now, GPON technology, ginagamit na rito within the campus and also within the building. No? They call this a passive optic local area network. So dito, this will eliminate the use of switches for every floor. Kasi unlike sa structured cabling natin, di ba, design natin, from patch panel to the I/O port is around 90 meters. Pero dito, you can go up to 20 kilometers. So that's the advantage of using GPON. And you can integrate in NVR mo, server, IPPBX, and also the internet. Sa network mo, pwede na gamitin lahat yan. You just program it that your IPPBX will be, IP phone will be connected to IPPBX. Yung IP cam mo will be recorded by the NVR, no? And then yung computer mo will be connected to the server. So, nagiging popular na ngayon yan for local area network, which we call OLAN. Okay. Okay, so this one, going back, ang critical about this fiber optic network, no, is the loss. No? We will be discussing only on section 4.1, 5.1, which is designed for fusion splices. Now, this standard was made first for the design and implementation. At the same time, for fusion splicer manufacturer, no? Kasi yung fusion splicer, noong una, hindi niya na inabutan yun, mano-mano yan. There's a microscope and then you have two fiber clip, tapos you have a powerful microscope, sisilipin mo, ikaw mismo mag-a-adjust. No? And that is before. No? That's why, ngayon, gumawa ng standard, dati ito is L12. No? L12 yung dinidiscuss ko. And because of a lot of changes, naging from L12, naging L-400 na. And that's how a lot of development in the telecommunication industry, especially in the outside plant. And the purpose of this is to have a negligible splice loss. And right now, most of the telecommunication, 90% of the fiber optic are fusion splice, or they are connected through fusion. Okay, so here yung methodology, ito yung sinasabi lang dyan na first is fiber cleaning, coating and stripping, cleaning of bare fiber ends, fiber clipping, and splicing. And the rest is pag-splice mo na, how will you test it, how the proof test, splicing protection, no? And at the same time, splice loss measurement. These are designed for fusion splicers. No? So kung gagawa kayo ng fusion splicer, ito yung babasihan yung standards. Okay, so review of the fiber. Fiber natin, three main part, the core, the cladding, and the coating. Okay. So right now, ito yung G651 natin, the multi-mode. This is the first generation, 62.5, yung pinaka-core, and then the cladding is 125 micron. And then you have na in TIA, ang tawag natin dito ay OM1, Optical Multimode 1. And Optical Multimode 2, again, it has a core diameter of 50/125, meaning yung 125 is the cladding. And then there's the next generation, OM3, which can go up to 1 gig, and the OM4, which can go up to 10 gig. No? So, ito ngayon, phase out na yan. Ito na yung ginagamit natin. OM3 and OM4, which are tinatawag natin na laser optimized. Because before, itong multi-mode na OM1, you cannot use that for laser. It's only used for LED because it's the source is cheaper. And now, ito yung ginagawa natin, the single mode. So, here, critical yung splicing kasi it's very small, 9 microns. That's why you have to observe, konting block lang yan, offset lang ng 1 micron, yung signal mo will be decreased 10%. That's why we have to make sure that this single mode will be aligned together properly. Okay. So first, the rest of the standard, kasi they want to put the fiber in a cable. So there's within this L-400, no? Meron doon paano paggawa ng cable. And how to put the cable, each fiber in a cable. Nandun na lahat yung mga design, putting protection. And one of the protection is against water, wherein they put gel. So kung mapansin nyo, if you have seen a fiber optic cable, pag binuksan nyo, parang maraming gel yan. And the purpose of that gel is to make sure that there's no moisture that will be developed inside. At the same time, that will be waterproof. No? But during splicing, you have to remove that gel. Kasi yung gel na yan, if the fiber is dirty, you cannot splice it properly. That's why, coming from the cable, we have to clean it. And we have different solutions that we have that we must use, no? Ang tawag natin dyan yung mga dilimunin. These are water-soluble na ginagamit natin panlinis ng cable. And we call it dilimunin. These are parang ano yan eh. Tawag natin dito galing sa halaman, no? Or herbal, no? Or so yan. And then these are mainly to clean the fiber from the cable. And then after that, we have to remove, so lalabasan natin yung fiber, no? And then next step is to do the coating. Tatanggalin natin yung coating. Because in fiber optic, ang ginagamit natin na transmission is the core and the cladding. The coating is just for protection and for color coding. But the transmission is inside the core and the cladding. So that's why we have to remove the coating and then join the fiber A and fiber B. And like for example, this one, this is a single fiber. So yan yung coating yan. Once na tatanggalin mo yung 250 micron, may exposed na sa atin yung core and the core and the cladding. But once katulad ng glass, or yung bottle, pagka hinampas mo yung sa lamesa, ano mangyayari? Pag nahampas mo ba, straight ba yung line na? Di ba crooked yan? Basag siya. So there are edges. Same thing as a fiber, it's just a mini bottle na pagka pinutol mo, magkakaroon ka ng cracks dyan. And we want to eliminate that later when we do the splicing. So we will be exposing the cladding and core alone. So these are different instruments that we are using. We have the tinatawag natin fiber optic stripper. Meron tayong mga battery operated or yung powered, So this is thermal, this is also thermal. In other countries kasi, minsan they need a thermal stripper para matanggal yung cover. But here sa Philippines, ito yung ginagamit natin. Mechanical stripper. But sometimes, pag nakita nyo ng mga ordinary technician, or minsan engineer, ginagamit din nila sa copper. So pag ginamit na sa copper, what happens is that, ang nangyayari, nadadamage mo yung pinaka-stripper. And that stripper is designed for 125 microns. Pagka ginamit mo yung sa copper, na-misalign yan, pag ginamit mo ulit sa fiber, you might damage the cladding during stripping. So make sure